In the next 9 minutes or so, I will quickly explain what is NX Motion, how can it help evolve your digital twin product quicker and with lower costs. You can see on the screen different examples on NX Motion applications, be it a landing gear, retractable sunroof, robotic arm or a medical bed. What do they all have in common? They are mechanisms, and NX Motion can help predict mechanisms' movements, loads and packaging compliance. It can answer questions, like, is there enough space between parts during operation or will they clash under certain conditions? Is my system stable enough? Is it safe for the human operator and surroundings? What are the loads in the mechanism connections? Or on each component? Now, NX Motion is a product based on the Siemens NX platform and within the SimCenter 3D portfolio offering. It is a solution dedicated for designers and design engineers, using SimCenter Motion Solver with license-limited functionalities, well, if compared to SimCenter 3D Motion. It is fully integrated into Siemens PLM system, through Teamcenter for simulation. With NX Motion, users can perform various multibody analyses, from articulations, to static, kinematic or dynamics analyses. Also, various types of post-processing are possible, like results plotting and animations, components tracing, enveloping, etc. Let's look at a quick example of a vehicle suspension. We shall analyze, using NX Motion, how it moves, whether dampers have enough travel space, and if the wheels can safely operate during the required maneuver, without touching the vehicle chassis. First, let's explore how the suspension moves and check the components' movements due to steering and jolting. As mentioned before, NX Motion is based on the same environment as NX CAD modeling and it directly consumes NX CAD data. You access the assembly navigator, like in modeling, to isolate the front suspension. An articulation solution type is ready for exploring the behavior. It was created after importing the NX CAD constraints and converted them to motion joints. You can act directly on the joints drivers by dragging in dialog or on screen. The motion behavior is here fully constrained by considering the joint limits, hence also related to the suspension requirements, like steering radius, jolting amplitude, etc. All actions are recorded for a complete animation review later, or saved to a spreadsheet, if needed. In our case, let's quickly perform an animation of the prescribed suspension steer and jolt. The user can visualize the selected sequence of movements and do a quick initial check whether any components collide or not. In conclusion, you saw a small glimpse of NX Motion at work, easily predicting the suspension kinematic behavior for prescribed maneuvers. Next step is aimed at validating the damper design with clash and clearance analysis in operation. First, we'll clean the display by not showing the motion object names. There are settings for your UI comfort quickly accessible. Second, let's define a packaging check. Here a damper minimum required clearance is 1 inch. You can measure between any CAD entity. Let's verify that clearance by jolting the left wheel. The clearance data is shown interactively on the display, while the suspension system is moving. NX Motion gives a warning when there is a clearance violation, highlights where the issue is and shows on the move by how much it is off limits. In this scenario, the animation is set to stop when threshold is breached. However, you can continue visualizing what the actual clearance is, even after that. Further study shows there is also a steering impact on the same clearance. In conclusion, you saw another example of how NX Motion can assist to quickly identify the operating clearances and help eliminate the problems early in the design cycle. It gave us vital information about the damper problem, helping avoid the costly issue during a later prototype development stage. A third step in this demo will show a damper subsystem trade-off and replacement, with immediate verification of the new design effects. Replacing the shocks is performed by simply switching to modeling while the NX Motion model still displays. One button click and you're in NX CAD modeling. Choose a different shock subsystem variant. Motion will now directly consume that new geometry, like, update its mass inertia properties based on new CAD, reuse solids, faces, points, etc. to relink the predefined connections or contacts in the model, and so on. Let's articulate to position to the minimum distance. With this new shock absorber, the behavior complies to the prescribed 1-inch clearance requirements. You may also need to explore the results and get more details for publishing to your colleagues. You can plot XY graphs, export to Excel tables, or compare between different variant solutions. Users can plot graphs data versus time, and animate the results along with the mechanism movement, for a better design at work overview. However, in this particular suspension study case, it's more interesting to plot the damper clearance versus the wheel vertical travel. That way, you can identify the minimum damper distance for that left wheel displacement, which tells you far more about how to modify the damper design to comply with requirements. The third conclusion: use NX motion to effortlessly perform components variance updates, by reusing the existing mechanism and new components CAD variants. Last part of the demo includes a wheel design space analysis. For that, we need NX motion to create a component trace or an envelope, after an analysis is run. For that, we shall use a solution that has drivers with time-dependent displacements. Drivers can be defined with math functions or curve table input. Multiple drivers can be easily sequenced as well. This is needed to describe the maximum positions of the suspension desired system components, which in our case is the wheel. In this model we shall use simple harmonic drivers for steer and jolt actuation. The motion envelope can be generated with absolute or relative reference options. This data can be used, for example, directly within the design front axle group. Now that the front axle is validated, we want to communicate the space requirement to the body and white designers. The wheel envelope, once generated, is used in modeling application without having to enter motion. Here, we're showing a simple clash analysis and corresponding issue, done by a body and white designer, based on the feedback collected from the front axle group colleague. A further clearance check based on the wheel envelope and the components of interest highlights the potential areas of contact with the chassis elements. Let us do a quick summary of the demo example. NX motion was able to efficiently identify the mechanism movement under given operation conditions and help the user steer the development of the damper unit. In addition, it assisted two designer teams on anticipating various packaging errors, saving the company valuable development time and reducing the costs due to early issues identification and remedying. NX motion is great, but some users may just want more. What if one needs to include tires compliance in the multibody run? Or co-simulate with Simulink? Or include components flexibility in the motion model? In that case, no worry, Siemens has it covered. Start using SimCenter 3D Motion. It will have the same look and feel, same platform integration as NX motion, plus, much more advanced functionality at user service. With SimCenter 3D Motion, users can benefit from access to various domain-specific verticals, advanced simulation methods, co-simulation capabilities and other dedicated methods for in-depth multi-body studies. Interested? Then contact your local Siemens representative for more details.